With SQL showing up in almost every job advert these days, it seems like SQL is going to continue to be in high demand. But if you've never used it or only have basic knowledge of SQL, it can seem extremely daunting looking at all those different commands and statements and queries that are available out there. And that can leave you stuck, not knowing what to learn and where to start. And this is no surprise because SQL is actually used by non-analysts too, like engineers, developers, to be able to build various things like databases. So therefore, there's a lot of different SQL queries out there that you as an analyst won't really use or maybe never use unless you have a hybrid role. So that's why in this video, I'm going to show you as an analyst what areas you'll be using SQL queries and statements, and I'm going to break it out into 5 different parts so then you're able to get a base understanding of SQL so you can just get by as an analyst, and anything else that gets thrown your way, because you understand this, you could easily just Google to figure out the rest. I'm going to show you this all by using a website called data.world. If you want to follow along using the datasets that I've got on data.world, the link is in the description below, and then once you're in, then we can start. So once you clicked on the link to get to data.world, you'll see you're now brought to where I have all the datasets ready to be used for this particular video. And if you scroll all the way down, you'll come to the file called Superstore Sales. If you just click on that, that will then take you into to view the data. So this is how you can view data in data.world. But to run a query, what you can do, you'll see here, we have this little hyperlink called query. If you click on this, this will then take you to the view that you need to start writing your SQL queries. And it's already written one for you already. And all it's doing is basically going, can you show me all the columns and limit it to 5,000 rows for the table sales. So all you'd have to do is just run the query with the button here, and you'll see the top 5,000 rows for that particular table, which brings us nicely to the first part, which is view data. This section is something that you'll come across in any role where there's going to be SQL required for it, because all you're going to be doing is being able to just look at a table anywhere, wherever you need to pull that information from, and be able to check what is in the columns and if it's actually what you need. And this is where it's very useful just to use SQL more than anything else, because it's nice and quick and simple, just being able to just quickly check, am I in the right place? Is this the data I need? And can I pull it into another BI tool or something like Python or R? And as we just saw, when we just did that query that automatically come up when we clicked on query for the Superstore sales table, I've created another query, which is basically using select star from sales. And if we run that, this is now looked at the whole table and pulled through all the columns and all the rows. And how that works is select is basically going, what columns do I need? The star is basically going, give me all of them. So you basically see all. And then from is then stating which table we're going for. And what data.world has done is actually made the Superstore sales Excel file into a table called sales. So now by running this, we're basically going, here's all the columns for this table, and I can see all that information. Great. So if you've just been wanting to find if this information that you need on this particular table is the correct information that you wanted to pull into a different system, or just grab that data so you can export it into Excel, then you've got it. But there will be cases where you will come across tables that are extremely large. And because of this, this can do 2 things. 1, take forever for the actual information to come through if you're pulling all the rows in. And 2, that you will normally use up a lot of the processor power that's happening within that database or that system, or even if you're connecting to something that is basically connected to a website, you could even slow down websites depending on what is happening with the table and where it's connected and sits in the ecosystem within the data pipeline. So you have to be very careful when you're actually pulling data, is that you're not spending too much time pulling it, because it can cause a repercussion down the line for other people, not just for you waiting. So to get around that issue, all you have to do is add limit, if you're using MySQL, to the bottom of that particular query that we just wrote, and then state how many rows you want. So in this case, I'm doing limit 10. So now it would only show up to here in the rows for the information that I want to see. And if you had a very large table, it will come back a lot quicker. So now if we just run that query now, we will now see the first 10 rows. Now, if you're using SQL Server, it is slightly different. It doesn't use limit. It actually uses top. And also top is not placed at the bottom like it is with limit. It's actually placed up here. So what you would do, you would write in top 10. And then if I just take out this won't work because this is using MySQL and not SQL Server, but it's just to give you an example of what it would look like in the sense of a query. This is how you would write to see the top 10 rows of that particular table without doing any more transformations on it. So if we go back and then take out the comments, as you notice when I do this, it's commenting out, which basically means if you want to be able to just have something that's a comment and not actually be part of your query, that's how you do it with the 2 hyphens. And then if we run again, we can see we now have our 10 rows. So say if you just wanted to check out the first 20 rows of a table, but then you also wanted to see it in a particular order first. So therefore you're ordering what you want to be able to see the actual top 20 of. In this case, what you would need to use within your query is order by, and this allows you to do ascending or descending. By default, it's ascending. So when you do it, you will see ascending, and I'll prove that point because if we run this query now, because we can see we've got select all from table sales, and then we're going to order by sales. So if we come over to here, we can see sales here, and then we're going to do limit by 20 rows. So if we run this query now, we'll see the 20 smallest amounts of sales at the moment. And then if I was to just comment back this in to show ascending, you'll see there'll be no change. And as you can see, no change. But if we were to do descending, we'll then see the highest amount. So if I take out that, do this, we then see the top 20 sales amounts because now it's in descending. So now you know how order by works. What we can do is see how we can do it with 2 orders at the same time. So if we want to order by one column and another column in ascending, we can do that by easily just adding in the columns that we want. So in this case, we're using state and then order date. So what that will then do is then it will go by state here from A to Z, and then also the order date from oldest to newest. So if we were to run this now, we'll see the top 20 based on A down to Z and all the dates from the oldest to the newest. So we can see here, it's done first state because we put it in that order. So therefore we see the order in A's. And as we can see, Alabama is actually showing up for all 20 here anyway. And then we can see we have order date in the order from the oldest to the newest. So we can see what we've got here is from 2014 May all the way up to, so almost a year. So you can see all the orders, there's been about a year's worth in the top 20 for Alabama. And this is how you simply just look into the data you actually need. And you will find, and this is from experience, this is probably the majority of what your SQL knowledge will be being used when you're going into a role that has multiple other tools at your disposal, and SQL is just there because they know that they need you to be able to actually go off, find the data, because some people don't know where it actually is and you actually have to go and find it yourself. This way they know you are going to be able to find that data and then pull it in and then do all the other analytical stuff within another tool. But there is another part to this. Just because you're pulling in the table and you found it now, you could just pull all the columns in, but that's not very efficient because there'll be loads of columns in there and lots of data that you probably don't actually need. And what's the point in spending all that time using SQL to grab the information you need only to bog down your analytical tool with all these columns and other data that you didn't actually need? So this is where you can start pulling the information based on your column names. Because we used the star originally just to find out what the columns were, you can make a note of the columns and then pull them in. So in this case, what we can see here is we're now just seeing just the order ID in the table for sales. And then all it was instead of putting select and then the star afterwards, the star is removed. You put in the column name and then from table sales. And as we can see, it's shown here. I'll just refresh just to confirm that's the case. And as you can see, it is. But as you'll notice, the order ID is using the same column title as what it originally was. But what happens if you wanted to add capitals to it or rename the column? Well, you can do this by doing an alias. An alias is as simple as adding as to the end of your column name and then just put in what you want to call it. So in this case, we have got select and then tell you which columns you want. And then we're going to use the order ID. And instead of just leaving it as order ID, we do as, and then we type in order underscore ID, both with capitals, and then from table sales. So if we was to run this now, this will now change to that name with a capital O and a capital I and D. So if we run that now, you can now see we now have a column name with capitals. And now we know how to change a name on a column. What you can do is do that on all the columns you need. So now, as I said, if you just needed certain bits of information within the table and not everything, then you can just basically go in, do select, and then put in all the different columns that you needed in the data. And then if you wanted to change the name of them, all you have to do is just add as and then the name. And then for each one, ensure that you put a comma after it. And then when you get to the last one, don't put a comma. And then you will get all these columns for the table sales, all the data with the column names changed to how they're set here. So if I was to run this now, we can now see we have a table that is just limited to just this information that we had here. So just remember, this is how it looked before. And you can see it scrolls all the way over. So there's lots of different information there. But now we are just limiting to that information. And that might be all you need. Therefore, that'll be the query that you'll be bringing in to your BI tool of choice. Or if you're just going to do additional analysis within SQL. So now you know how to actually just get the columns you need to reduce the amount of data you're pulling in. Now I'm going to show you how you can filter the data so you can get just the data you need on the basis of filter context. So to do this, what you need to use is where, and where allows you to filter as you would expect to be able to filter. So with the different areas, you have equal to, which is the equal sign. You have greater than or greater than equal to, and then greater than, and less than, which is the arrow to the left, and then less than and equal to with the arrow to the left and the equal sign. And then you got two options for not equal to. You have the two arrows side by side, or you have the exclamation mark with the equal sign. So for this example, what we're going to do is look at the sales table again, and then we're going to add a filter where we're only looking at orders since the 1st of January 2016. So to do this, all we're going to do is select all those columns that we wanted before, which we've done here. So select all the columns, all the renamed, what I've done, copy and paste from the original one so you don't have to keep writing them out. And then down here, you'll see I've put where and then order by, but I've also put an order by here. And the reason being is to show you, again, with SQL, it has a particular order in where it needs to operate. So if I was to run this now, we will see this is going to filter where order date is greater than or equal to, and this is how dates are written because they come out year, month, day, 2016 of January the 1st. And then I'm going to order by ascending order date. Remember, order by will be ascending by default. So if we run this now, we'll then see the oldest orders, but starting from that particular date, because at the moment you've got ones that are 2014, 2015. So really the first one should start with that date or a date after if there isn't the 1st of January. And as we can see, there isn't the 1st of January, you've got the 2nd of January. You have all the orders from the beginning of 2016 now in ascending order. Now, if I was to show you what this would look like if I did order before where, so if we do order by is now the same order by, done by order date, but done before where, it will fail. And it's because SQL doesn't understand why this has happened before it. So that's why you need to do it after. So you always need to think, if you're doing a filtering or any aggregation, which I'll come to later, that anything after that is always done at the different parts after that point. So you always want to ensure that you're ordering by after you've done a filter. So if we put this back with a comment out and then run it again, we can see we now have a table with that information. So now if you just wanted to get the information in the table of the sales of all orders post the 1st of January 2016, this is how you do it. So as we can see, we now have a nice table, reduced the size, so it makes everything nice and quick. And also we're just not being bogged down with additional information that we just don't need. So that's how you can filter and bring in the columns that you just need for your analysis. So now we covered the basics of how to use where to do some filtering. There's additional parts that you can add to a where statement to be able to pull through additional filtering context. So if you wanted to say be able to find two dates and then look at the data between them, you can use something called between. And the opposite is true. If you wanted to look between two dates, but outside of those two dates and just take out the information that's between those dates, then you can use not between. And if you wanted to build on multiple different filters, you can then use not where again, but instead you use and or, which gives you the options to be able to say, is it this and this to show you the information, or is it this or this to then show that information. But then also, if you are doing something where you want to look at, does it include this or this, you can use in, which will then allow you to do the same of being able to go, is it this region and this region instead of or this and this. Therefore, you can write it and it just looks a lot cleaner as well. And as you'll see in the examples, and the same is if you wanted to omit those particular ones, so you didn't want it to be this and this, then you can write not in, and that will give you a result of the opposite of the information you put in there. So if we move over to the query that we've got here, what we're going to do is start using between and to be able to show how they work if you want to be able to see the results for all those columns in the sales table where order date is between the 1st of January 2016 and the 1st of February 2016. And if we was to run this, we would now see all the order dates that are between those two dates. And because I haven't done an order by, the dates are in a random order, which is fine, but we can see if we scroll through, you can see there's nothing that is out of the between dates. You can see all that is between those dates. But now we've seen that, let's have a look at a few more other filters that we can bolt on to this. So if I bring this down, we can now see I have some additional filters built in that I can just add just to be able to show how these would work. So if I was just to comment back in the or here, what this will do is this will add a filter that includes east, but because it's not and, it means that anything that is between here, it will pull through the dates based on the order date unless the region is east. And because of that, all the other regions will be between here, but east, it will show everything because you're using or. So if I was to run this now, you can see west there is all within the between dates, but east and east all the way here, you can see we got some in September, we got July. It's using the context of or. But if you just wanted to do the same where you have between and then just filter by particular region, well, we can just do and. So if we bring in and in this case, we want to go and is it region west or region east? So then both that information will come through, but only for those regions between 1st of January 2016 and the 1st of February 2016. So if we run that now, we can see the only regions we have are east and west because we've said, does it include west or east? And that's all it does. And you'll see the order date is sticking to the between that we've requested. And that's all because it's went where I want to know this filter and this filter and then stick them together and then you get your result. But like I said, the or is good for that particular part there, but then written like this, what happens if you wanted to add more? This is where in comes in really handy. So if we comment that back out and then comment this one out, this is going to give the same result, but as you can see, it's written in a more easier to read format because now we're doing and region in, and then you just put in brackets all the different parts you want to be able to filter on. And in this case, we're still doing west and east. So if I was to run this again, we will see, and then let's just scroll down to see how many rows we've got. 104. Let's go run query. And if we scroll down, we will get 104 rows, as I said. And again, look, it's all west, it's all east, and it's all between January and February 1st, 2016. But then let's say you didn't want to see west and east and you wanted to see, I forget what the other two are now. What was it? South and central, I think. Then you can just run and region not in and then put in the ones you don't want in your filter context. So in this case, I don't want to see west and east, and that's where and region not in comes in. And if we run this, we now see central and south. I was right with the between context here. So again, no east and west in here. And all the dates are between the 1st of Feb and the 1st of January 2016. just so we can make this look a little bit nicer, let's do an order by, where we're just going to order by region. So it'd be central first and then south afterwards, and then in the order of dates from the 1st of January all the way down to the 1st of Feb. So if we run this now, we can see central, their first order between those dates was on the 4th. And then if we keep scrolling down, we can see their last one was the 31st. And then for south, it was the 2nd. And then if you scroll down, we can see it's the 31st. And that's the great thing about when you order by more than one, you get to see that information split out like that. And you can check the data, see what you want, and there you go. So now you know to use between, in, and or as part of the where statements. What happens if you had a situation where someone comes to you and went, oh, I need some data that is just basically contains this, or maybe a name, but all they know is that it begins with an M, and therefore you need to pull everybody who has an M within as the start of their name, as an example. And you can do the by using like and not like if you didn't want it to include it. And then what like allows you to do is to go just like you would do if it's contains, but by putting in what you want the like to be like. So say if you wanted, as in this example here, we are going to look at what the product ID is with off at the beginning. We can use off with the percentage sign afterwards to be able to show everything afterwards. Now, if you were just to do it without using the percentage sign, as we've got written down here, no results will be found because, and this will just be looking at anything with just off in it. So if I was to run, you won't get any information. As you can see, we don't have any data. Now, if we were to do the same, but this time with off with the percentage sign in it, then that's when we will get all the results where the product ID starts with off and then has anything else after it. So if we run that, you can now see all the product IDs that begin with off. But say if you wanted to see all the product IDs and then you wanted to look at something which had, like I said, like a name, and then you got something before or after, this is where you can start to build in a different way to use like. In this case, what we're going to do is go, we want to filter if region contains something that is like, and then in the brackets, we have S in the middle here. So what I'm trying to do here is go find something that has S in it, but at the same time, anything before the S include. So at the moment, if I just purely went by S without the additional bit here, we would get the same information that we got when we did off. And that's because we don't have anything after. Now, if we wanted to be able to look beyond S, because we don't have anything in region that ends in S, we would want to go, let's add another percentage sign. So now it's like going anything where an S sits at it, it will show you, which is great if you wanted everything with an S. And in this case, we have got south and we've got west and east. But ideally, we just wanted to get anything that was going west or east. So we're going WES and then it's just a T afterward. Now, if we knew that, we could just go say T and that would be fine. And it will just bring through those and then it will remove south. But what happens if we didn't know? We just knew the letter before the end was S. That's where you can do an underscore. And with the underscore, that is basically picking up the next letter that is after. So if I was to run this now, you can see it's now capturing the same information, but instead where we had with it picking up south without us adding the T, we are now getting the regions that we needed. And then if we were just to order that by region and order date, we can see here's east and there's west. Like I said, if I did it like this, it will include south there. And that is how you use like. So now we come to the last part of this section, which is going to be covering the filtering if null or is not null. Now, the sales table does not have any nulls in it, so this is where I'm going to be using a different table for this particular example. And if I show you what this looks like, if I go into sales left join, which is this one here, you can see we have some examples of where there's no data. So under category, we can see row 2 and row 9 both have no data. So if we'll go back to the table So basically, if we are going to do where is null on, in this case, customer ID, so as we can see, we have no nulls showing up. So if we were to run this query, we will get no results because there's no nulls, because here we're going where customer ID is null. But if we were to do the same for not null, so if we go is not null, we'll get all rows show up. Now if we were to try this on the column that does actually have nulls in it, which is category, remember there were those 2 before, if we were to run this now, it would just filter by those 2 rows. And as we can see, there they are, because no data, no data. So these are the nulls. So that's where it's pulled through that information. And again, if we run to the exact same again, but this time doing is not null, those 2 won't show, but the other ones will, which I think is 11 because I said it was 13 before. So if we run this, we got 11 here, and therefore we can see any of the ones got an actual category, they will show, where before they did not because it's picking up the nulls. And that's how you simply filter by null. And as I said with the first one, this is probably going to be the majority of the roles that you would apply for or move into as an analyst who has another tech stack available to them, because all you're going to be doing is picking out the data that you actually need. And like I said, if you have never touched SQL before, never used it, seen all the different ways people use it, read all these articles and everything, and you're like, oh, where do I even go with this? Like, I don't even know enough. In reality, a lot of the times you are literally just doing this. And I've been in many roles where I've done literally just this, nothing more. And the only reason why I've ever used SQL in those roles for a little bit more stuff is because I was just playing around trying to find information. But generally, I was just grabbing what I needed and sticking it in Power BI. And I think because most roles now require you to jump into this new data warehouse that this business has built, or they've got this new fancy CMS, or any other tool where you can access the table data using SQL, people will want to know that you're able to do that. And that's why, if anything, if you know that, this will get you by quite a lot of the time. But if you've got something where people need more information, or you're going to be doing a lot of analysis within SQL, then you might come across times where you need to do more information or pull more information. But if you're just pulling into a tool, generally you'll just be getting the table you want, and then you'll be worrying about all your data modeling on the other side and not need to think about, oh, I need to join this table and that table. However, if there are cases where you do need to join tables, then it's a good idea to learn how to do joins. And to do those, you have 4 ways of doing this. But this first part, I'm going to show you how you can join using join stroke inner join. Weirdly, it's both, it does the same thing, 2 different names, but they do exactly the same thing. And just to confirm how an inner join works, an inner join is where you've got 2 tables, and then when they connect, it's the middle part that matches. So as long as this link from this column links to this, it will pull through that information. Anything that isn't there, it's removed from that table, and anything that's not in this table is removed as well. So only left with the actual data. Now, this isn't the best type of join to use if you're using especially something like sales data, because if there's any data missing from the other table you're using, this will omit it from the sales table because that doesn't exist in this table over here. And because of that, you would want to use other joins. But just to show you how you can just join a table, because at the moment, this sales table and the other data, everything matches. So it will all connect, but going to show you how it looks when you're able to select the table information that you need. So you get, here's the columns from here, and then rename and put them all together. Just make one nice table out of the 2. So first thing we want to do is select all, because at the moment we just want all columns because we don't know what we're going to get yet. And then from sales, and this is the key part here, is this is where you put join or inner join, because they do the same thing. This is the section where you put in the table that you want to join to the sales table. So in this case, we're going to join customer table to the sales table. And to do that, you type in the table name dot whatever the column name is that you want to link to, and then equal sign. And then for the other table, on your join, you put in that table name dot whatever linking column name is. And in this case, it's both customer ID. Now, if we were to run this, we will scroll along and you'll notice 2 things here. One, this is no longer just saying customer ID. It says sales.customer ID. And the reason is you can't have columns the same name. So therefore it's now changed the name of customer ID to sales ID. And that's because you come over here, it's pulled in from the customer table, the same ID, but from the customer table. And so that means you got it twice. But then also you got the customer name and segment as well, which is the information you really wanted. And now, just to prove the point that if you use inner join, it does the same thing, is I'm going to now do, instead of using customer table, we're now going to use the product table and using inner join product on sales.product ID, because that's the ID we're going to be using, and then also product ID for the other table, which we're joining to. And then if I was to run this now, you'll notice customer ID doesn't say sales.customer anymore because that's not the one we linked on. This one, sales.product ID, is. So that's why that shows there. And as always, we have the product version of it as well. Exactly the same information. Again, product.id. And then because these are new, they don't have product dot and then the name next to them. They're just pulling through. So now we have all the product information in. But what happens if you want to have more than one table joined together? Then this is how you do it. So as we've done before, we have our select and then from, and then we've done our inner join or join. And this time we're going to start with product and then on, and then the two columns we want them to link to from both tables. This time the sales table, product ID equals product ID from the product table. Now, if you left it there, it would just pull through the product information, but we also want the customer. So all you do is just add another join at the bottom, and then you put in customer and then on and then sales. And then we're using customer ID on both. So we do sales.customer ID equals customer.customer ID. And if we were to run this now, we can see we now have sales.customer ID here and sales.product ID. So that means when we scroll along, we'll have both over here. So as we can see, product ID, because that was the first one, and then the categories, and then we got the product name. And then because we put on the customer ID next on the customer table, that's why that one's coming there. And then we got the customer details there. If we switch them around, customer would be there and product would be there. So now we got all these different ones in here. We don't want all the columns where they're duplicated, and also the naming isn't the greatest. So the way to get around that is by using the alias that we learned earlier. All you have to do is, like before, just put in the columns that you need. And because now we know the name of the columns because we found them, we can now rename them. So where it says sales.product ID there, we're not including other product IDs in there because we just need the one. And the same goes for the customer ID as well. And then all we're doing is just pulling through those columns, and then we're just doing the join, just like we did before, where we have product first, linked by product ID, and then customer second, linked by customer ID. And if we run this, you can see we now have cleaned up columns, removed those duplicate ID columns, and then just have in the order that we wanted the information. So instead of having product and customer at the end, we now have them in the order of customer here and then product here, all nicely laid out. So now we know how to do that for cleaning up an actual table once we do a join. Now I'm going to show you the different types of joins and their limitations, but also their uses as well. So for the 4 different types of joins are what I've already covered, inner join, which is we have 2 tables and where it only picks out the information where both tables are matching on the column that is connecting the 2 tables together. Then you have left join. And what left join does is keeps all the information that exists in the left table and then adds on anything from the right table onto it. So in the example which we were just going through earlier, if we were to go with the sales table, and if there was any information missing on, say, the product table or the customer table, then there'll be rows removed from that data. So you actually be losing some sales in there. If you use the left join, you won't lose any. You'll just have blanks where there are areas where there was no connection. But like I said, in the previous example, there's all the information there. But in here, you get to see how it works. And then we have right join, which is the opposite to left join, where any of the information that is on the right table stays as is, and it only connects with anything from the left table onto it. So therefore, it's the opposite of what is the left join, because now you're only getting the information from the left table that's connecting to the right table. And then we have full join, which is basically we'll connect both and we'll just bring through both bits of information. There'll be information on the left table that will show up in the right table, and there'll be blank parts of that table where it's all connected, because if there's no match, you will have blank areas where there's no match on whatever table it is. And you'll be thinking full join would be the best idea whenever you do a table, because then it's pulling through everything. But really, if you have a particular source table that you're always going to be using, left join is actually the best option, because that should be your source data and then you're pulling in additional information to it. But there are many cases where you might be doing different parts where you need to have all that information, or you want to check both tables, checking if you want to go, oh, is there actually anything missing? Instead of doing a left and then a right join, you can do a full join and then you can find out what's missing that way. So there are benefits to being able to do that. But if you are simply just trying to get on some information onto a table that's your main table, that's where you want to use a left join. But with that in mind, let's go through the different examples and show you how they work. So let's start with join stroke inner join. What we've got here is we're using the new tables that I've got that are sales left join and then customer right join. So if I open up customer right join now, and we can see we have all these customers here. If we go to the sales left join, we can see we've got all these different customers here and then their orders that they've done. There are 13 rows in this data. So if we go back to our query, we are now going to take that left table with the 13 rows in it, and then we're going to join it with the customer table. And then we're going to link by the customer ID on both tables. And what this is going to do is go, just show me everything in the sales table that has a match with everything that's in the customer table, and then remove any rows that do not match. So if we run this now, you can see we only have 11 rows. And you'd be like, oh, that means we've lost 2. So what can we do to then figure out what happened to those 2? So as I said, we can do a right join, we can do a left join, or we can do a full join. So in this case, if you wanted to know what was missing from the sales table that wasn't showing up in the customer table, then that's when you use a left join, or you could use the full join. And then if you wanted to know what was missing in the sales table that's showing up in the customer table, that's when you do a right join. Let's start with a left join, because what this one will do, as I explained earlier, is it will bring through everything from the sales table, so all 13 lines, not just the 11 that we saw before, but it will show you which ones were not connecting to the customer table. So if we go left join instead of join or inner join before, and then customer right join, and then on, and then we're linking again customer ID. And if we run that, we can now see we have our 13 rows again. And then if we look along here, we will get to see who was missing. So they are missing and those are missing. So who have we got? So it looks like Aaron and Jack are the ones that were missing from the customer table. So that means we have our sales table as it was, and then with the addition of the customer names and their segments as well, but also including the ones that aren't there, and therefore that information is null. And this is why left join is always the best one to use, because if you're using sales data here and you did an inner join, therefore you would lose those 2 lines and you would be reporting on incorrect sales just because those 2 didn't show up. So it's always a good idea to ensure that you always stick to your fact table that is going to be on your left, and then left join with whatever information you want to add onto it. But the same can be said if you wanted to do a right join, which is what we're going to cover next. And if we were to run that one, we'd still get the same amount of rows, but you'll notice that the information that was in the sales table is not there. And the reason is because it's using everything that's showing up here. But because there were 2 people who were showing up in the customer table, just like there were 2 people not showing in the customer table for the sales table, they are now showing. So we can see a David and a William here, which are totally different names to the other 2 that were there before. I think it was Aaron and Jack. Those no longer show because those are not actually in this table. So everything in this table is now being pulled across over here. And that includes where people are being duplicated because there's additional lines. So even though this table has Greg in it once, see, Greg's only in there once, he shows here twice because there's 2 sets of sales data in there. So he's had 2 orders. So that's why he comes through. But as you can see, we are not getting any sales information because we don't have any for David and William. But we've also lost Aaron and Jack's sales amount. So that's why you wouldn't really use a right join unless you had it round the other way where you were using the sales table on the right and the customer table on the left, but you wouldn't really do that anyway. So that's where it's useful for being able to see what information is missing on the other side, which brings us nicely to full join, which like I said, shows you everything. So we're going to have even more rows this time, which based on what was missing before, I believe should be 15 now. So if we were to run this, because now we're doing full join, as you see here, exactly the same layout as all the other ones. It's just literally changing that name there. And then you run it, and then we look and we see we got 15. And the reason is it's because it's showing what's missing from one table and the other table. And if we go up here, we can see Jack's back, and so is Aaron. Still blank here, but because we're now including everything on the other side, we got David and William showing up here. So this way we can see they're missing from here and they're missing from there. So really it's down to when you need to use for particular types of purposes. And I know I keep saying use left join. As an analyst, generally this is what you're going to be doing. But if you are going to need to look at what is missing data from other tables, comparing and so on and so forth, then that's where you can start to use stuff like full join. And also you can use join, inner join, if you really are not worried about losing data that doesn't show up. But there's always a risk with that. And that's why it's always good to have whatever your source main data point is, to say like a sales table, and then bringing in that information onto it so you can get that additional data. But in most cases, literally the joins aspects, you probably do more when someone is building something than doing it for analysis, because if you are needing to look at multiple tables, generally you are going to be using some form of other tool for your analysis. So you'll be pulling, like we were covering before, the table, bringing it in, another table, and then modeling from that to be able to get that information. But it's a good skill to know in SQL, so you're able to understand how you can join set multiple tables, test data, check it's got the information you need. That's where these joins can come in really, really handy. And so now this brings us to aggregation. Now, aggregation is extremely useful if you're needing to do any sort of quick analysis on a table, or just to kind of see what's there. And you can do this by doing various queries based on how you want to do the aggregation. If you just wanted to do an aggregation of what is the information within a particular table, then you can use various things like count, which is what we've got here. So if you just wanted to simply count the number of rows, all you would need to do is after select, do count, and then count whatever column you wish to count on. In this case, I'm just using region and I'm doing it from sales. Now, because I clicked on this, it's already run it, but if I just run this, it's saying that within the Superstore sales data, there are 9,994 rows. Now, if we were to come down here, we can see we have region here. And if we click on it, we can see that none are empty and non-empty is 9,994 rows. So you do get that information, and some tools do allow you to pull up that information anyway. But if you don't have that information, this is how you can quickly find out how many rows are in that particular table. So now you've done your first aggregation with count. What happens if you just wanted to be able to count the number of unique values that are showing within a table? So let's say, for example, we have region. We want to count how many regions are there within the whole table, not how many instances of them there are, which is what we kind of did with count. What we want to know, how many regions are there in the whole table? And we can do this by doing count distinct. Now, count distinct isn't count and distinct as like one name. It's actually count with distinct added into it. If we wanted to count how many regions there are in the whole of the sales table, we would go select, count, and then within brackets, instead of just doing like we did before region, which did then the whole count of all the rows in the table, we do distinct in front of it. And what that will do is give a result of how many regions there are. So if we run it, we will get 4 region. And if we come down to here, we can see region. We click on there, we can see it's saying that there are 4. But if you just wanted to know what the names of the regions are, or whatever values it is you actually need, then that's when you can just do select distinct. So you don't need count, because that will just give you the number. But if you just want to see a list of all the different regions, we can just go select distinct region and then from sales. So we're now going to see all the regions that exist in the sales table without it being a long list of all the rows that we had originally. And as you can see, we have south, west, central, east, as we know from previous sections, we know those are the ones that exist. And this comes in really handy when you are working with large tables and you might need to go, I need to get a list of all the different cities or customer names or just the order numbers, anything like that. This is where select distinct will be great, because that will just aggregate everything and just get rid of any duplicates, and you just get in a list of all the information that sits within that particular column. So now you know how to count and look up unique values. What happens if you want to sum? All you have to do, just sum. It's as simple as that. So instead of where we done count before, we're now going to do sum, and we're going to do it on sales. So we're going to sum up the whole sales that exist within the sales table. And that's just simply going select sum in brackets sales, because that's the column, from sales table. If we run that, we can see that is the total sales within the sales table. But let's say you didn't want to just look at the total sales on the sales table. You only just wanted to look at region West. Then what do? That's where you can just do the same query, just add on where region equals West. And that's what I've done here. We have our sum of the sales on the sales table where region equals West. And if we were to run this, we can now see the sum of all sales for region West. So now you know how to pull the information by aggregating that way. What happens if you wanted to see the sum of all sales for each region? You won't want to sit there and just create a query for each one, pulling each region, because one, you don't have the name, and two, just cumbersome. So what you can do, you can create a table that'll give you the 4 regions down the side and then the sum of sales for it. So we can remember here, let's start what, 725. Let's go with that. That's what shows for West. So if we wanted to get a table that will give us all regions and then the sum of their sales in the other column, you would need to go select region, because region is where you want to go first. And then we're going to count the number of rows just so we can see how many lines there are. But then the main thing we want is the sum of sales. So we're going to have 3 columns. One's going to have the region name, the middle one's going to have the count of rows, and the last one will have the sum of sales for the region. But to be able to pull this off, if I was to just run that as is, you'll just get this error message and you're like, oh, why are you not working? I've asked you to give me region and everything. And the reason is you need to use a command called group by, and that's what you want to set or you want to group by. So in this case, we want to group by region. And if I was to run this and then also include order by, just a sum, just to make it look a bit cleaner, we would now get the result of what we wanted here. And as you remember, West that we looked at before, that started 725. So it's putting through that information. We know that. And now we've got everything, and we can see the number of rows that exist in the table for each one, which would total up to that 9,994. And then, yeah, we got the sum for each different one. So now you know how to use group by. What do you do if you want to group by something that doesn't actually exist in the table as such? In this example, we want to be able to take the year of an order and be able to look at the count of rows and the sum of the sale for each year. Now at the moment, we only have the visibility of order date, but this is what we want to focus on, being the year. How we get around being able to group as year under one is by creating the year out of the order date. And you do this by simply typing in year and then in brackets, putting in the date you wish to get the year from. And because I've made that the first column, that's going to be what is going to be on the first column. And then for all different years, we're now going to count the rows and get the sum of sales. Now, because we have this created, and this isn't just like before where we had region and we just type the name. This is the actual statement that we need to be able to put in to be able to group by as well. And then also I want to order by it as well. All you would need to do is put the same logic in as group by and order by, because you don't have year. And if you did group by order date, that's not correct, because you don't want to group by order date. You want to group by the year of the order. So that's why you need to put the logic in there and there. And if we were to run this, we now have year in order of descending with the total rows for each year and the sum based on the year of the order date. So now we covered those various different aggregations. There are a few more that you can include outside of count and sum, and those are average, which will give you the average of the column, the min, which will give you the minimum or the earliest or the least of the value in the column, and then the max for the max or the most in that particular column. And now using our date as order date with year, again, we're now going to do all the aggregations as columns, rename them, and then order, and then group by using year again. So this will give us 4 years again, but this time with the count of rows, with the number of sales as the title, and then sum as sales amount, average as average sales amount, min as lowest sale, and max as highest sale, because we're all using sale as the main column for each of these aggregations. So if we were to run this now, we can see the different years. I haven't put an order in, so they're just coming in as they are, with the number of sales, which is the number of rows, the sales amount, then the average sales amount, the lowest sale amount, and then the highest sale amount. So we can see the highest sale amount actually happened in 2014, and the lowest was the year later, but that also had the highest lowest sale. That makes sense. And that just brings us to the last part of the section of the aggregation, where we're going to be covering the filtering of a group by. You cannot use where in the context of once you've grouped by to then be able to filter afterwards. You can run where before you do a group by, but that probably isn't the result that you want. And a good example of this is if we use the same table that we just seen before, where we've got all the information here. And what we want to do is basically filter by where the average sales amount is less than 230. So if we look here, we can see those two are above 230 and these are below. So really we want 2017 and 2015 as the result. So we want to be able to filter so you'd only show these two rows. Now, if we was to do this with a where before the group by and did it on the aggregation, it will break, as you can see. So if we take out that one and then we rerun again, we still have the data that we had before. But then if we was to put a where we weren't doing the aggregation and just doing it purely on sales, this will change the result. So as you'll see here, once I run this, we're now saying sales. So actually it's not looking at the aggregation of it. It's looking at all sales lines, and then it's only pulling the ones that are below 230 if we do this. But in reality we didn't, we wanted the average. So if I was to run this now, we'll still see all the same years, but this will drop because all the sales it would be filtered by are below 230. That'd be fine if that's what you wanted. You wanted to be able to remove any of the sales that were over 230 in value. This would work. But this is not what we wanted to happen when we were doing this particular case. So if I was to run this, you'll see this completely changes. And as expected, we're now looking at the average sales amount, because we've moved everything to below 230, is actually working out around 50. So if we were to take that back out and then run again, get us back to our original table, we need to use the group by version of where, which is called having. And having lets you do all the stuff that you can do with where, but you do it for a group by, and it always happens after your group by. So now we have what is our aggregated amount, now less than 230. And this should show these two here only when we run this, because now we're filtering on the aggregation, which we couldn't do with the where. So if we run this, we now see the two that have the average sales amount of less than 230. So now we covered all the parts that you would need to get by as an analyst in your new role, or a role where you need to be able to know how to use SQL. And the best way to actually understand what you've actually learned is to practice. And this is why I'm going to use this section to be able to cover what we would count as some ad hoc requests. So any sort of random requests that you might get from someone, and how you would get that information using SQL. But then this is also can be seen as types of interview questions that you might get as well. So sort of use this as a good base to be able to start learning from. So let's look at some examples of what might come your way as an analyst using SQL in your role. So for the first example, I'm going to actually include another thing to learn, which is case. And case is just like an if or if else that you would use in other programs. But with the query that's been requested, it's going to be a simple case of just creating a flag that tells you, is this over 450 or is it under 450? And for this particular request, where we're getting asked, can you include a flag where ATV is over 450. Now we don't actually have average transaction value currently created because what they want to know is how many orders were placed for each region in 2016 and the average transaction value, and then a flag to say if it's over or under 450. Because the average transaction value is based on the number of sales based on the number of orders, is the number of sales divided by the number of orders to give you your average transaction value. That has been created as a separate column as well. So if we look at this request, because we know we want each region in 2016, we're going to select the year of the order date and rename it year. We're then going to get region and then as region, and then that will pull in all the regions. We then need the number of orders, and to do that we want to do a count distinct just to ensure there's no multiple orders with different lines in them, and that will give us number of orders as the column title. And then we want the sum of the sales, which is sum of sales as, and then we're calling it sales amount there. And then we come to the bit that is where we work out how to create the ATV, and that is sum of the sales divided by count of distinct order ID. So again, order number again there, and then as, and we're just going to call that ATV. Now, this is where we can now do our flag. Because we have the ATV and we know how it's created, we can now build in a case. So where before you would have a column and we're normally creating a new column with a line, this I've broken out over this whole part here so you can see how it's actually created to make it easier to read as well, is you start by putting in case, and then you do what would be equals or when this happens. So when, and then we're going, the whole calculation here that we used for ATV, we are putting in here. So then it knows this is creating the ATV. When it is greater than or equal to 450, then give a result where it says ATV greater than or equal to 450. And if it isn't, then you do ATV less than 450 by doing else. And then to ensure that that case is now closed, you create it with end at the end, and then we're going to rename this to as ATV underscore flag. So now we're going to have a column that's basically going to say the year and then the region, number of orders, sales amount, ATV, and the ATV flag. Now, but because we wanted to have it for each region as well, and we also wanted it for 2016 only, we then needed to group by. We do a group by after we've done the table sales, year, and then region. And then because we want to know only 2016, we use having year of order date equals 2016. And as you can see, it's already run here when I already opened it. But if we just run, just to prove this works, we now have the result of what we wrote here. So basically, now we need to know how many orders were placed for each region in 2016 and the ATV. We can see in 2016, they're all there. Here's all the regions. So here's the number of orders. That is the average transaction value. And then we can see Central and East are the ones that had an average transaction value over 450. And that completes that particular request. So for the next request, they've asked, what were the top 10 most ordered products in 2017 based purely on being an order, not the quantity, and including category. So what they want is basically to know, so how many times did those products show up in an order, but you wanted the most orders of that product and actually see the top 10 of them, but only in 2017. But also we need to have information that's not in the sales table. We're going to need information from the product table to give us the categories as well. So as you remember, when we went through our bits to do with the join, we know we can actually create columns first. So what you could do is just simply do a join from sales to product, to do select all, and then do from sales left join to product, and then link to by product ID just to find out what the names are. But because we've dealt with this before, we know what the names are already, so we can just type these out. And because we're going to be grouping those products all under 1 year and including the number of orders, we're going to have to do a group by as well. So the first thing you want to do is create your year by order date column, and then we want to bring through the product ID. It doesn't matter which one you bring it from, be it sales or product, but in this case it's brought through from the sales table. And then what we need is the product name, the subcategory, and the category from the product table. So we just add those in and then rename as where needed. And then to finally get the number of orders, we do a count distinct on order ID again to give us the number of orders. So now we've got all that information there. We know that we're now going to pull through just that information from both those tables, ensuring that the sales table is always got that information in it. And then because we now have this particular group here and this group here, we then need to do a group by of all the columns that we need. When you've got multiple columns with values of more than one in them, it will need to aggregate, otherwise it will fail. So I'll show you as an example. If I just remove product category and take away that and then run, see, you get an error because there is a missing aggregation going on. So if we were to add that back, it will work if we run it now. So as we can see here, but to finish off the actual query, we know we need to only look at the ones that are 2017. So again, we just filter by 2017, and then we want to order by the number of orders. So because we've created the number of orders, we need to order by the same logic used to create the number of orders column. And then because we want the highest to the lowest, we then move that to descending with using order by, and then we just limit to 10 to get our top 10. And this is what we got here. So we can see particular product was the one that sold 8 orders in 2017. And then there was quite a few with 7, and then there's some 6s, and there's probably some more 6s outside of the top 10. These are the top 10 that showed. And that's how you get the top 10 of orders in 2017 and the names if they're from a different table by joining them using left join. So far, we've actually done some quite complex queries that we needed to create just to get that information. But as I mentioned very early on in the video, there are cases where people just want to have just information that's on a table. So with this particular request, someone's just asked, can they have a cut of all the data in the sales table that is related to customer BH11710? And that is simple because they've just asked for a very simplistic request in there, not asking for any particular columns or anything. You could go back and actually ask for more detail on the information, but sometimes if people are just asking for that, they don't always know what they want to see or what they need to see. So it's always good to just give them more if they allow to have visibility of more of the information than give them less and guessing what it would be, because majority of the times they don't always know exactly what they need to see. They might know partially, but not always all. So it's always good to just send all just to be on the safe side. So in this case, all we're doing is showing all columns from the sales table where the customer ID matches the one that they requested. So if we was to run this, we now have the table with all the information here, and we can easily just download to CSV or XLSX, or if you're using another program, you can sometimes just right click and be able to get an export from the table just by clicking on it, right clicking, or you can copy table and then save it in an Excel format, however you please. So it's easy as that to get that information. But as you can see with the next request, they didn't have all the information they needed and they wanted some additional information, which now they thanked you for sending over the data for the person, but can you include the product names and subcategories too, because they don't know what the products are based on the product ID. So again, we just do select all. We're now going to do it from the sales still, but now we need to bring through the product from the product table. So we do a left join to the product table. We point the sales product ID to the product table product ID, and then we go where, again, filtering by that particular customer. Now, if we was to run this now, we have the same information we had before, just with the additions of the product table information down the side here. And again, you can just export and send it. And to probably save time, if you wanted to delete these, you could easily just export to Excel, delete the column that you didn't want, or delete columns that they don't need, and just send it over. Then try and sit there and remove each one, or setting the column names under select. So now we dealt with that request, let's move on to the next one. And this one is asking how many different customers purchased in each region for each year and the average sales per customer. So now we know what we want to do is find out how many different customers purchased in each region for each year. So we need to do a distinct count of the customer IDs in the particular year for the particular region. Yes, you might have customers over multiple regions, and therefore those will show up more than once because they'll show up in both regions, because how it's split out, because they're not distinct under the region. But the main thing is how many unique customers are there, and also what is the average sale of the customer. So based on how many orders they actually do, what is the average sale for them as well. So to do this, we need to do another group by, and we also need to create some additional columns with some calculations in them. And we start with select as always, and then we start building out what the columns are going to be. So we're going to have region, because we know we're going to need that for the group by as well as the year of the order date, because we need to look at for each year as well. We need to basically have all 4 years split with all 4 regions as well. And then we need to count how many unique customers there are. And we do that by going count distinct and then on the customer ID, and then we rename that number of unique customers. We then need the amount of sales. So we just sum sales, call that sales amount, and then sum of sales divide by the number of unique customers to get the average sales per customer. And we're going to do that all from the sales table. And then to ensure that that information comes through how we need it to, we then group by region and year. And then we're just going to order by the average sales per customer column here. And as you see, we actually just call it this instead of me putting this logic in, because you can actually do that, but it's always a good idea to try and use the logic that you have in the calculation. But the problem is if you change the name here, it will break it here. So as long as you're not changing what is the calculation, it's always going to be the same. It will work, but you can get away with actually putting in what you called it in there as well. But it doesn't work in all programs. So now we have all the different regions, all the years, but we got it ordered in highest to lowest from the average sales per customer. So the South in 2014 didn't have as many unique customers, but the sales amount was really high. So even though they had these customers in, the average sales of the customer was very high in that year. And if we go down, we can see 2017 it was the lowest for Central. So for this query, there are examples of where you will get some last minute requests to just give some information as quickly as possible. And annoyingly, it's not available in any current reporting. And because of that, if the data is available and it's not needing any additional calculations outside of SQL that are housed elsewhere, then you can quickly get the information you need using SQL. So with this request, your manager is in an important meeting and an exec has asked her, what is the profit margin percentage for copiers in 2016 and 2017? You're not in this meeting, so she messages you on Teams and asks if you can send the numbers ASAP so she can feed back. She probably needs these numbers really, really quickly if an exec has asked. This is just going to be quicker if I just use SQL. For this information, we know we do have profit exists in the table because it's here. And then we got the sales amount here. So we want to divide profit by sales amount to get the percentage of profit. We also need to know it by year of 2016 and 2017. So to do that, we get the year and then create that as order year. We then pull in the subcategory because we know we need copiers and copiers fall under subcategory. And we're doing that by bringing in the product ID again from a left join using product table and connecting with the product ID on both tables. And then we want to get the sum of profit divided by the sum of sales to get the profit margin. And if we were to do that without these additional ones here, we would see the number as a number and not as a percentage. We need to group by what are the product categories and the year. So we can just see it grouped by those 2 years and that particular product category. And then we're filtering by the product category to be copiers. And then we're doing and year is order date in 2016 and 2017, which is what's in the request. And then we're going to order by year descending. Now, like I said, if we run it with this particular profit margin, we will get a result where you get the profit margin, but shown as 0. But maybe they want to see it as a table and you're just going to screenshot that and send it over. So in that case, what you want to be able to do is then add in what would be a percentage sign. And you can add in a percentage sign by using concat. And this works really well whenever you need to add anything depending on where the positioning is. So you can put it at the front if you wanted to do like a $sign or something. But as you see, if I run it now, it will just add a percentage at the end, loads of decimal places, and not actually giving me what the percentage is because it still says 0. So to get around that, you need to format it. And to format it, you can round it first to reduce to just 1 decimal place, which is where round comes in. But then also because this is basically a less than 1 number, if you times by 100, that will then make it a whole number and therefore will then bring it up to be 39.7 or 39.8 even, and then 35.8 as well percentage. So if we run this now, we can see we now have our copiers for 2016, 2017 with the profit margin in a proper percentage view, which you can just send over to your manager in Teams, giving you the result, and you can see there's 4% difference as well. So it's actually improved over the previous year. And you can see how powerful it is to be able to just play around and try these different requests and just sort of understand of like, oh, what can I be asked, and make yourself feel more comfortable creating queries in SQL, because once you understand the basic logic of how SQL works and start using it, it would just feel like an additional limb you just had, and then it just makes life so much easier. And then you think, how did I not understand this before? And if you're still stuck on bits and everything, always keep back referencing. I've got loads of different chapters in there so you can keep referencing back, skip to the bits that you need to skip back to. But what you really want to do is just practice, practice, practice. And the best way to practice is on different data sets. And there's many different data sets on data.world, but there's many different data sets elsewhere that you can bring in to data.world, or practice by loading up a program that does SQL as well. And you can find all these different type of data sets in the video on screen just here, because this will give you a good insight of all the different data that you can find around on the internet and play around with.